over 1. So you always move to the right 1 and up A. So we moved over 1, up 1/2. Or the other way you can think of it is take all your y values of our original equation and take them times 1/2. No, that's with all your parent functions. All of them, yep. If they were in this form. So here, you want me to prove it? Yeah, if you were told to do it like that, yes.
So normally what I would have done was like
Up 1 over 2?
Yeah.
Yep, that is a lie. You were taught by a teacher who did not understand what they were doing.
Wow. So that's like, 5 years.
Yeah.
Are you saying
The 2, okay, in the original one, we had the order pair 2, 4, right? Okay, so to get the new order pair, I take the y value times the a value. So in my original equation, I had the order pair. In my original, I had the order pair 2, 4. So to get my new order pair, I take that times the a value. So that gives me my new order pair 2, 2. So that's how I got my new one. So anytime you need new ordered pairs, more ordered pairs, you take the order pair from your original function, and that's how you can get more ordered pairs. So I could do the same thing with square roots. A square root has the ordered pair of 4, 2 in it, right? If I plug 4 into a square root, I get 2. If I had half square root of x, then an ordered pair inside that would be 4, 1. Because I take the y value times a half. Yes, so I'm so sorry that happens, but that sort of thing happens sometimes. Especially in, I shouldn't say anymore because I'm being recorded, and this might get out, and you can bring this to your teacher and go, Mr. Collette hates you. I don't hate people, they're, okay, again, I should just shut up. I can't help my superiority. Again, I shouldn't have said that, I'm being recorded, damn it. That's okay, post-editing, right? Okay, so you good with A? Yeah. Okay, let's put this together. Now, I don't know. I'm going to do this in steps for you. So I'm going to make a big mess of my graph. The reason for the steps is kind of show you, oh, I should put a square on that, sorry. It's kind of show you order. Wherever you do this, these actually transformations, order of operations apply to transformations. We don't always have to follow that if we understand our transformations, but order of operations actually do apply to them. That's another thing that sometimes gets mixed up a little bit, because some teachers explain it as the negative reflects you over the y-axis. Have you guys heard that before? Some teachers do that. Well, if I take this and I move this around, which would be up here, and then I do my reflection, that's going to reflect it down here. That's incorrect. because that's totally negated my my moving around. So to make sure that we all end up with the same graph, in the end, our transformations actually follow order of operations also. So, just to go through this, again, if you understand what you're doing, you don't always have to follow them. For example, whenever we do our reflection, we can actually just reflect it over the vertex instead of reflecting over the y-axis. But the true reflection is actually happening over the y-axis. So just to go through this, I'm going to do this one in like terrible detail. All right, so our first transformation, if we're following order of operations, should occur inside our parentheses. So that should be the first transformation that we do. So according to that transformation, H says that I should shift it -1, so that means to the left 1, right? All right. I'm following my order of operations. Order of operations says parentheses first. Okay, next thing in the order of operations is what? Okay, but the exponent just tells me what kind of function it is, so I can ignore that. So multiplication. So my next thing is the a value. That's the next thing I should deal with my transformation. So the negative and the 2, so that tells me I should do that, right? Okay, so this point stays where it is. These points I'm going to take down here and here. Right? Because my slope is now -2. So I go over 1, down 2. Right? Okay, now my final step. So my final step is I have that plus sign on the outside. So according to operations, I can now do that addition. Which means I'm going to shift it up 3. So 1, 2, 3. Okay, so there's my final graph. Now, that was a lot of insane work, right? So let me show you another quicker way to do it. But when in doubt, whenever you start getting confused by the transformations, that's how you can go back and do it. You go back, just follow your order of operations, and that's how you make sure that in the end you have the correct graph. Okay, I'm probably just going to do 2 more. I'm going to do one more like this, and then I'll do one with the B real quick to show you what the B does. Again, I'm not going to get too concerned with the B yet because we'll cover that more second semester. But they introduce it here, so I want to make sure I introduce it here. Okay, now, I told you towards the beginning, a great way to do this is to base everything off of the vertex. So, one of the things is, once you learn how the parent function and what the parent function looks like, my goal is that you guys can just, figure out where the vertex goes and graph everything off of it. Okay, so my h is 2, my k is -1, my a is -3. So these two things tell me that my vertex is going to be at 2, -1. This tells me that my slope is going to be 2, -2, 1, right? Oh, -3, I'm sorry. Okay, so I'm going to start at 2, -1. 1, 2, -1. Okay, I know that my function usually goes over 1, up 1, but my slope is -3, 1, so over 1, 1, 2, 3. Since this is a parabola, I know it has a matching point on the other side, and I have my graph. That's what I would prefer you be able to do. I put my vertex in by shifting it, and then I just graphed off of my vertex. Again, if you ever get bogged down by transformations, especially with some of the harder problems, always go back and use your order of operations if you think you're doing something wrong. Or if you look in the back of the book, you can't figure out how they got something. Okay, I want to do one more, and then we'll be done, I promise. Anyone still need that? Okay, let's see. I'm on example 7. Okay, I'm just going to do that one real quick just to show you what B does. Actually, I may need to, let me do 2 examples. I'm sorry. I lied to you. I need to show you something else about B real quick. Okay, just to make sure you know what square root of x looks like. Square root of x starts here, has 0.11, 1, 2, 3, 4. The next number I could take square root of is 4. Square root of 4 is 2. Next number would be 9, so I'm not going to put that one on here. So that's square root of x. What negative inside there, what negative in front of the x does, is it flips it horizontally. So the negative would make my graph look like this. So that's the graph of square root of negative x. So a negative inside of the function flips you horizontally, flips you across the y-axis. The reason I couldn't do this with the squared function, with the parabola, is because you would never be able to tell, because it's symmetric across the y-axis. So if you flip it, its two sides look the same. Okay. I want to show you one more real quick, because just in case anything like this comes up. I don't think it does, but I don't remember for sure. Okay, this is one of those places where what it looks like lies to you. If you've had a teacher teach you this before, they may have lied to you. I didn't lie to you, John. Okay. Which way do you think that shifts?
Over and
Over which direction?
over the y-axis and then forward.
Not up 4. It's on the inside, so left or right? According to the way it looks, it should shift left, correct? Okay, but it shifts right. The reason is, if we go back to this, B is on the outside of this, which it shouldn't be. It should be inside. Dang it. I messed that up. I lied to you. I am a total jerk. Doesn't matter. None of you understood that anyway, right?
So I should have X'd out. I didn't
Doesn't matter. You're never going to go back to that again, right? That negative needs to be pulled out of that. In order to make it work correctly, X cannot have anything in front of it.
So
Yes. The negative is B. Whenever I wrote that, it should have looked like this. In order to make your transformations work correctly, X has to be by itself. X cannot have a number in front of it. So if there was a 2 in front of that X, your shift would actually only be over 2. Which is what comes into play whenever we get into the trig stuff. I don't think you have anything that complicated. This might be all the more complicated as you get into this. So this shift is actually over to the right 4. 1, 2, 3, 4. Then we go backwards. H. Because it's inside. If I had a K, the K would be, I would have a K that would look like this. That would be what K would look like.
So would the problem be that when it's negative x plus 4 when it has brackets?
So if I had a K, that's what the K1 would look like. I put the square brackets in just to differ between the brackets. The shape of the brackets doesn't matter. Is that what you're asking?
There has to be what does it know on the extra model? Or which side is that
Would it be where? What do you mean? I'm not understanding the question. Okay. Yeah. Yeah, H is always off. All right, you guys good with that? All right, let me give you your assignment. I know there's a couple of you who need to leave soon. I'm sorry, you guys had some good questions. I didn't mean for notes to take this long.